what is NumPy? NumPy is a library for the Python programming language. So it's adding support for large mathematical functions, multidimensional arrays, and along with large collection of high-level mathematical functions. For example, like addition, subtraction, or even complex mathematical functions. It supports a lot of mathematical functions. So it make us it makes us easier to perform linear algebra, especially if you are working on machine learning. So this can make us easy to perform linear algebra, especially. So this is very, very important to perform high-level mathematical functions. So generally, it offers a comprehensive mathematical functions and generating random numbers, transformers, Fouriers, and many more, especially linear algebra, because machine learning focus on linear algebra. So this library is important to perform linear algebra operations, mathematical functions, high-level mathematical functions, generating random numbers. So how can we create NumPy? So we can create a NumPy using a library, Python-based library. First of all, we should import the library. Let's create a NumPy array. First, import the NumPy as NP. So once you imported this library, you can perform a lot of mathematical operations, mathematical functions, a lot of things, linear algebra operations or functions. You can generate random numbers. So how can we create array in NumPy? So first, use.
Sorry, but we cannot. Sorry, but we cannot see what you are writing now.
Okay, you cannot see. Okay. Let me share you.
Okay, it's now okay.
Okay.
Yes, we can.
Yes, it's fine.
Okay. So to create a NumPy array, we just use the library NumPy. First import this library. So if this library is not installed on your computer, so you should have to install this library first. Just use pip install NumPy on Jupyter notebook. So this is actually Python. Jupyter notebook supports this NumPy by default, so you don't need to install again. But if in case it is not supported or installed by default, you can install just like using pip install NumPy. Once you install this library, just import the library as a variable. So it says requirements already satisfied because of it is installed and it is a latest version of NumPy 1.215. So to create an array of NumPy, we can import this NumPy and we use a function array. This is a function from the NumPy library, and inside this function, we should specify a square bracket to create a list of a sequence of arrays. Then list the items inside this square brackets. 2, 3, 4, For example, this is a one-dimensional array. Then in a square bracket, you can specify the list of items, the list of elements inside this array. Okay, there is NumPy has no attributes. Okay, there is a spelling error here, double R Y. Okay, then we can print the array. Just print 1, 2, 3, 4 is a list of an array. It is a one-dimensional array. So how can we know the dimension of the array? So there are a lot of functions, attributes to identify the type of the array, the dimension of, or the size of the elements inside the array. So to know the dimensions, just we call the variable array name dot n dimension or nd. So we can print this array is one dimension. So a single dimensional array or one dimensional array. So we can identify the dimension of the array using of the array. And the size means the number of elements in the array. Size of the array using array name dot size. These are not a function, but these are the properties or attributes in the function array. So we can call the attribute name the array name dot attribute name. Once you know the attribute name, you can call that, and you can simply identify all the results of the attributes. So the size of the arrays are the number of elements in the array. So we can count, we can simply count the number of elements in the array. 1, 2, 3, 4. There are 4 elements in the array. So it is a one-dimensional array. The number of elements are 4 in the array. So we can also identify the shape of the array. Shape of the array means just the size or, the dimension of the array, the dimensions of the array. If we have multi-level or multiple dimension of array, so we can simply identify how many number of rows, how many number of columns in the array using shape attributes. So here, so this displays in tuples of integers that identifies the size of the array in the rows and in the columns of the array. So here we have 4 elements number of arrays. So this represents the size of the array in the tuples of this result. And the other attribute in the array is just types of the array. What type of data we have in the array? So we can simply identify the type of the array. The type of the array, array name dot dtype. So in this case, the type of the array is integer because all numbers are integer numbers in the array. So it simply returns integer type. If we may have a floating number or a double number, so simply you can identify the type of the array using dtype attributes in the array. And there is also type. Dtype and type are different. Type A. This identifies the object of the array. The object of the class, which means what is the type of this class? This is the NumPy n-dimensional array, not the type of the element in the array. not the type of the element in the array. But if you want to know the type of the element in the array, you can simply use the array name dot attributes. D type attributes. But if you want to know the type of the class, type of the object, simply use type. Then inside this function, we call the array name or the object name, simply the object name, because this type of object is array object. So this is the way how we can identify the size of the array, the shape of the array, and type of the element or type of the data in the array. And the other is, there is another way of creating another way of creating an array. The other way of creating is sequences of array. Sequence of array. For example, let's create another sequence of an array. No, sorry. The arrange. We can create array using arrange function. In the first creation of an array, we have simply list the elements in the array, but we can provide a sequence of elements using arrange function. For example, b np dot arrange function. Then we can provide the size. The number inside this. How many number of sequences? Yeah. For example, 6. So it provides the number from 0 up to 6. That is, the index starts from 0 up to 6. So the sequence of array would be like this. This is the way how can create a sequence of array elements in the array using arrange function. If we use shape, for example, if we wanted to reshape, or if we want to create many dimensional arrays using a reshape, there is a reshape function that can create, just give rows and columns. For example, we have 6, 0 up to 5. Then we can give 2, 3, 2, 4, or 3. Just divide these arrays into 2 rows and 3. 2 rows and 3 columns. This is a 2-dimensional array having 2 rows and 3 columns. This is the reshape function that can reshape the size of or the dimension of the array. And how can we know how many number of dimensions we have in this array? We can simply call the array name dot ndim. So we have 2 dimensions of the arrays, 2 rows and 3 columns, 1, 2, 3. And the number of dimensions we have, we call shape. Yes, we have 2 rows and 3 columns. This is a 2-dimensional array, and we can simply know how many number of rows and how many number of columns we have in the array. So you can call this attribute shape attribute that can know. So inside this tuple, we can simply know how many number of elements in the array by multiplying this dimension numbers, which means 2 times 3 is 6. So we have 6 number of elements in the array. By multiplying the dimension numbers or the size. And we can simply know the size like this, 6. You can now by multiplying the dimensions, or you can simply now by calling the attribute size. And another way, for example, if we create an array like array 2, 3, 4. This is a sequence of sequences in the array. So this is another way of creating an array using like this. So here, so this is the sequence of sequences of an array, creating an array. So it automatically converts to array when you provide like this, a tuples, a sequence, not a tuple, it is sequences of elements in the array. So it automatically converts to the array when you call this array. So this is a single dimension of an array. And the other is we can also create an a floating point arrays, like for example, numpy.array 1.2 3.1 I mean 2, and another 2-dimensional array 3.4 3.5. Got 3. Field elements must be 2 or 3 tuples. Okay. Okay. Tuples just convert to tuples. And sorry. Tuple must have size 2, but has size 3. Okay, tuple must have size 2. Okay. Canvas interpret this one 2, 3. Okay, 2 has a data type. Canvas interpret 2 as a data type. Okay, I forget here there is a square bracket. This is what I made a mistake. So inside this square bracket, we provide a list of tuples, and it automatically converts it to arrays. D, yeah, it is converted to. That's I made a mistake while writing, because when you just provide, this is an error, like you cannot provide a tuple inside this function without a square bracket, because to identify the array, we use a square bracket in the array function. That's why it generates an error, because this is a 2-dimensional array. If it is a single dimensional array, you can simply use this one. But if it is a 2-dimensional or many dimensional array or any dimensional array, so the square bracket should be provided here. Okay, is there any question? Okay, and the other is we can specify the type of the data inside this array function. If, for example, f something like NP array 2, 3. Inside this array function, we can provide the type of the type of this array elements. Like, for example, if you wanted to specify the type of this array, you can use these attributes, the type, then provide specify the, for example, complex. If you want to create a complex array, you can simply argument for array given by the type position number is okay. Still, I forget this one. There is square bracket here. What I made an error is here. Yes. So the type of this array is we can simply identify the type. It is a complex number. When you print out this array, it displays a complex number. I think you know about complex numbers, right? Just number plus any J symbols at the end. It is a complex number data type. So if we want to specify, for example, int 64, it converts to integer like 2, 3, 4, 5. So you can simply specify the type of the array while creating an array, right? And the other is, there are another 3 functions. The functions, for example, if you wanted to create an array with having all elements 0, that is zeros function. The sequence of elements will be 0. For example, A, NP, zeros, 2, 3. All the elements will be 0. Look, zeros function, a 2-dimensional array, 2 rows, and this is another way of creating an array using, rather than using the range, you can specify the dimensions inside this array function. So zeros is to create all sequence of elements 0. If you want to create all sequence elements sequence of elements to ones, you can use np dots ones. You can give the dimensions 5, for example, 3, 5. So all elements are here. I have provided 3 rows and 5 columns, 1, 2, 3, 4, 5 columns. This is the dimensions of the array. So the total number of elements in this array is 15. 3 times 4 is 15. We can simply multiply the dimensions and we can get the number of elements in the array. And the other element, we can simply create, use MBT. MBT function is to create, or the initial content is randomly random. So it depends on the state of the memory. So we can create MBT numpy. MBT, for example, the size 34. 8. So it's simply generates random numbers. So it depends on the size of the memory, not So this type of, for example, simply you can identify the type of this. It is floating number, floating or double number. So it generates any type of elements. And so those are the very beginning functions to create array or NumPy in Python. So you can simply create a NumPy array using a range function. You can create NumPy array using a sequence of sequences, and you can create a NumPy array using zeros function, ones function, MBT function, and many more. And you can also identify the type of the array elements using D type. You can simply know the size of the number of elements in the array using size attribute, and the dimensions of the array using dim and dim. So there are a lot of functions. These are the very beginning of NumPy Python-based library. So very, very important, especially if you are working on machine learning and data science, because machine learning is based on linear algebra and calculus. So every linear algebra function calculation can be performed using NumPy. Okay, anyone having question? Hello?
It's clear.
Okay, it's clear. So, yep. So in the next time, we will see the more details of NumPy, especially complex high-level functions of mathematical functions of NumPy. And we will see how can we plot using matplot library. Especially we can statistical like mean, median, and other percentile, quantile, and any mathematical statistical functions using NumPy in the next time. If you have any question, you are welcome. Anyone having any question? Okay, so tomorrow at the same time, we will have part 2, focusing on other mathematical functions. So today is all about this session. Thanks for joining the live session. So if you want the recording, I will share you the record via the Telegram chat, so you can watch later on.